Hello, my name is Michael Morra, and today I will be teaching you how to find the instantaneous rate of change. The question I will be doing is from the Nelson Advanced Functions Grade 12 textbook, and it's page 115, number 5. It's from Chapter 2, Finding the Rate of Change and Investigating Different Functions. Question relates directly to the unit, as instantaneous rate of change is a form of rate of change.
The question reads, the height in centimeters of a piston attached to a turning wheel at time t in seconds is modeled by the equation y equals 2 sine 120 degrees t. Question A. Examine the equation and select a strategy for finding the instantaneous rate of change in the piston's height at t 12 seconds. Part A. The first thing I like to do is take a look at the graph I'm finding the rate of change of. This is displayed on the screen now. As you can see, it's a sinusoidal function, and at 12 seconds, it's almost at the x-axis. Evaluating the equation, we can now select a strategy. The strategy we're going to use today is by the formula and not by the graph. The formula is a very precise method that is right for this equation. The equation is the IROC, or instantaneous rate of change, equals f of a plus 1,000th minus f of a minus 1,000th all over 2,000ths. This formula is derived from the average rate of change, but is different in the fact that thousandths are being added and subtracted, and the denominator is a constant. To solve this formula, one must find what f is at both of those values, and then plug it into the equation. Final answer for A will read, the method I will use is by formula. I will use 12 as the t value and evaluate the IROC at 2 points 1,000th from each side of 12. We will now be starting B. B reads, use your strategy from part A to find the instantaneous rate of change at t equals 12 seconds. To do this, we will carry out our steps from part A that we had previously discussed. First, we'll be finding the time at 12 plus 1,000th. For instance, we must replace t with 12 plus 1,000th whenever we see it in the equation, hence the left side and the right. In the second step, I have just plugged both sides into the equation. In the third step, I have just multiplied 120 degrees by 12.001. In the fourth step, I have evaluated 2 sine of 1,440.12. This is what the sine of 12.00.
Because this function is sinusoidal and it reaches 0 at 12 seconds, the two values attained are equivalent.
The same steps were applied, but this time, instead of adding 1,000th, we are subtracting one. The same solving is done, and a different answer should be attained. Because the value is sinusoidal, we get a value that is the negative of the previous one. Looking back at our original equation, you can now see that we know two of the unknowns we didn't know before. Now that we know them, go ahead and plug them in your equation. Our equation should now look like this. This can now be simplified by using the double negative, adding the two values on the top, and dividing them by 2,000ths. At the end, you should get an answer of IROC equals 4.188787. It's important to remember that when we find the instantaneous rate of change, it is just an estimate. In order to find the exact instantaneous rate of change, we will need calculus, which is not of our level. For this question, the answer that we have provided will suffice. Our estimate answer will follow. Therefore, the estimated instantaneous rate of change at t equals 12 seconds is 4.188787.
Thank you for watching my video. I hope that you found this useful and know that this question can help you in many pathways in life, this including engineering and anything that has to do with cars. It might be particularly useful if you want to know how fast a wheel is spinning at any point in time.